I had in earlier work looked at the question of how hard it would be for evolution to stumble on a completely radically new protein, that is a protein that has a new structure. And what we wanted to do, because the answer that I got in that work was that it would be extremely hard for evolution to do that, we wanted to back up 2 steps and ask about a much simpler problem. So this is the problem of consider an organism that has a bunch of proteins that work and they do their particular functions. How hard would it be for evolution to craft a new function on an existing structure? So to produce a slight modification of an existing protein that does a different job, does a different task in the cell. And so when we looked at this smaller question, both Anne and I thought it was quite conceivable that the answer would be that these sorts of things can evolve, and we really wanted to find out how long it would take for them to evolve. And we were somewhat surprised when we scanned the literature and looked at all the studies of this kind of thing and found that a lot of people had asked how hard it is to get a protein to move from one function to the next function. And all of these studies were unconvincing. At least they did not convince us that the evolutionary story could work, because they all found that these sorts of transitions, functional transitions that preserve the overall structure, are much harder than we would have thought. They take far more mutations, or despite all the efforts of these researchers, they couldn't actually get the transition to happen. But what we wanted to do is actually examine this thing from the perspective of people who are willing to offer a critique of Darwinism. So all of these prior studies, when they report the results that they get, they always fit them within the Darwinian paradigm and say, here we got an enzyme to perform a new function. And for various reasons, they were not convincing. We wanted to say, hang on, let's do this very carefully and be willing to draw the conclusion that, in fact, the Darwinian mechanism doesn't work. So what we did is just found out by experiment what sorts of changes it would take to get protein A, the first one, to do the function of protein B. And we ended up very carefully doing single changes and examining their effect and finding that it would require 7 or more changes. And that doesn't sound like a huge number. Maybe it's 8 or 9 changes would make the thing work. We couldn't actually get it to work because we very carefully zeroed in on particular changes, and those did not get the transition to occur. But what it did allow us to do is to go back to a mathematical model and say, well, if to get this transition to happen would require, say, 8 changes, how long would it take for that sort of transition to happen in a real bacterial population? And it turns out once you get above the number 6, and even at lower numbers actually, but once you get above the number 6, you can pretty decisively rule out an evolutionary transition, because it would take far more time than there is on planet Earth and larger populations than there are on planet Earth. So that was the big surprise. And we're the first ones that I know of who have undertaken a study of this kind and been willing to step back when we get the result and say, what does this mean for the paradigm? Everyone else tries to force their results into the paradigm. So I think that's the big contribution that we've made.